In this video, we will do a probability measure word problem. So the example says that a potato chip company is performing quality control on its potato chip bags. A randomly selected bag is deemed acceptable or inadequate. Inadequate bags are either incorrectly filled, which can happen if there's too many chips, or too few chips, or mispackaged, which can happen if the bag is not sealed or the bag is damaged, or both, meaning it could be incorrectly filled as well as mispackaged. The probabilities are given in the table below. So this table lists different events like the bag is acceptable, which has probability 0.74, or the bag is not sealed, which is probability 0.07. And each of these events I've labeled with a letter. So for example, A for acceptable, M for too many chips, F for too few chips, and so on. Okay, so there are a lot of words here, but let me get to the first part of the question, and then I'll let you pause it to write this down. Okay, let's zoom out a little. And part A says, well, find the probability that a randomly selected bag is, part A asks, incorrectly filled. So definitely take maybe even 3 minutes to copy this down. There's a lot of words here. So let's, after you do that, after you've got it copied down, then go ahead and stop hitting the pause button, and then we'll talk about it together. Alrighty, so hopefully you have it copied down. Let's go ahead and start to talk about it together now. Okay, so part A is talking about the probability that the bag is incorrectly filled. Incorrectly filled. So let's think about how we'd find that. So when the question talked about inadequate bags, it talked about two categories of inadequate. There's incorrectly filled ones, which is what we care about for this problem. And incorrectly filled could either mean, well, there's too many chips or too few chips. So those collectively are these two categories. These correspond to where it is incorrectly filled. And moreover, these two events, too many chips and too few chips, they are disjoint. So what we're after here is incorrectly filled is the probability either that we have too many chips, which is M, or, and the word or makes us get a union, or that we have too few chips, which is the event F. So the probability of an incorrectly filled bag is equal to the probability of M union F. And because these two events, too many chips and too few chips, they are disjoint, this equals the probability of M plus the probability of F. And the reason again is since M and F are disjoint events, they can't happen at the same time. All right, and let's plug in the numbers. Too many chips, the probability is 0.11. For too few chips, the probability is 0.09. And adding them, we get 0.20. So about 20% of the time, a bag is incorrectly filled. Okay, so that is not good for this potato chip company. All right, so let's do part B. Part B is asking, what's the probability that a randomly selected bag is incorrectly filled or mispackaged? So for this question, I want to give you the opportunity to try it first. So pause the video for about 2 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it and try part B for 2 minutes. Okay, so let's first talk about mispackaged and where mispackaged is in this event table. So the question going up says that mispackaged means either the bag is not sealed or the bag is damaged. So these two categories refer to where it is mispackaged. So incorrectly filled as well as mispackaged, those are the two ways that a bag overall can be inadequate. So that is going to give me an idea for solving this question in a very quick way. So when it talks about incorrectly filled or mispackaged, notice that this is the complement of acceptable. If it's incorrectly filled or if it's mispackaged or both, it is definitely not acceptable. So part B is talking about the complement of the bag being acceptable. So if we want to find the probability that the bag is incorrectly filled or mispackaged, that's going to be equal to 1 minus the probability of the complement. And the complement is that it is acceptable. And the table gives us that. That probability is 0.74. So we get 1 minus 0.74. And this works out to 0.26. So about a 26% chance that this happens. So in terms of our goals for this section, we have finished our last goal. We've solved a word problem about probability measures by converting the information that was given to math symbols.